Coffee. For many of us, it's what keeps our wheels of creativity spinning. And running out of coffee means running out of fuel. And therefore, some might say that not knowing how much coffee is in a coffee pot is not simply a question of convenience, but an existential one. You might think I'm exaggerating, but what if I told you in the early 90s, more than 2 million people logged onto the internet to see if one coffee pot at Cambridge University was full or empty? The story begins here, the computer laboratory. It's now known as the Department of Computer Science and Technology, but it remains at the epicenter of technological discovery as it has been for decades.
The computer laboratory at Cambridge University, where the scientists loved their coffee. It was so popular that they focused a camera on the percolator so that everyone in the building knew when a fresh brew was on. A year later, they gave it its own internet site, unaware that more than 2 million people would share their addiction.
When we did this, it was one of the earliest, if not the earliest, cameras on the web. And it has gone from that novelty aspect to being of historic interest remarkably quickly, and I think perhaps on the web that can happen much faster than anywhere else.
Dr. Quinton Stafford Fraser, one of the people responsible for developing the Trojan Room coffee pot, is still working in Cambridge today. We caught up with him at the Center of Computing History exhibition marking 30 years of the World Wide Web, where we talked a little bit about the world's most famous coffee pot.
I'm Quinton Stafford Fraser, and I'm here in this wonderful Web at 30 exhibition, which is celebrating 30 years since Tim Berners-Lee turned on the first website. In the early 90s, I was a research assistant in a group in the computer lab that was working on multimedia systems. And actually, this is a great location because, as it happens, if I punched a hole through the wall back there, I'm only about 60 meters away from the room where I sat 30 years ago, working on things like, can we send high-quality video over computer networks, something that really wasn't obvious at the time. We had a coffee pot, much like this, and we all shared it. But some people in the group weren't in the same room, they might be several floors away, and so they would often come down and try and get a cup of coffee, only to discover that actually it was stale, or empty, or cold, or whatever. So the way we tried to solve this problem was that we got a camera, which we had left over from another project, and we pointed it at the coffee pot. And we wrote some software which, a few times a minute, would grab an image of the coffee pot, and then we had a client program that you could run on your desktop that would periodically go to the server, get a little icon-sized image of the coffee pot, and display it in the corner of your screen.
This was a networked camera. That means the image of the coffee pot could only be accessed by others on the same network. This means people in your building or on your same floor. But in 1993, a new web browser called Mosaic created a new wave of possibilities by allowing images on the browser.
We ended up sort of in the middle of the night starting this project that we called Mosaic. What we were trying to do was just put sort of a human face on the internet. The internet at that point was a tool for researchers and scientists.
This new human face of the internet raised a host of questions for the coffee pot team back at Cambridge.
And we were wondering then, what would happen when the web browser talks to the web server and says, please give me an image, if the web server doesn't give back the same image every time? So we thought, where have we got a source of constantly changing images? Aha, the coffee pot camera. So my friends Dan and Martin modified this to output HTTP, and so that meant that anybody in the lab could look at how much coffee was in the pot, and as a side effect, anybody in the world could see how much coffee there was in our coffee pot.
It was the strong desire for caffeine, coupled with the creativity of a few computer scientists at Cambridge Computer Laboratory, that resulted in this creation of the first webcam. It's incredibly difficult to overstate the significance of this innovation, especially now, during the pandemic, where not having a webcam means not being seen.
It grabbed people's imagination and became something of a star of the early internet. Having burrowed through lots of relatively static web pages, document-like screenfuls, you suddenly emerge with a little window that gives you a view of somewhere else in the world. Now, every computer has camera or maybe multiple cameras attached to it, even the ones we carry in our pockets. And that enables a whole new era of exciting research involving connecting computers and cameras together.
I am Dr. Mara Mahmud. I'm a research fellow and affiliated lecturer at the Department of Computer Science and Technology.
Technologies such as the webcam have become ubiquitous, and it's unveiled a new era of computer vision research that has seen some incredible breakthroughs. We sit down with Dr. Mara Mahmud to understand how she uses computers and cameras.
So I work on analyzing facial expressions, human facial expressions and gesture, and mapping them to different conditions, especially mental health conditions such as anxiety or depression. I then started applying similar techniques on animal behavior understanding. So Charles Darwin, 150 years ago, was the first to study changes in the facial expressions and movement of the animals and how these can be linked to emotions. And recently, vets have been working on building grimace scales that can actually encode changes in the facial expressions to signs of pain. So for example, in sheep, changes in the nostril shape, so for example, a V-shaped nostril would mean the animal is in pain, a flipped ear to the back, or also tight cheeks. All of these are signs of pain in sheep. Sheep are prey animals, so they have evolved to hide signs of weakness and pain so that they don't look vulnerable to predators. So some of these signs that might be signs of diseases can be subtle and not easy to detect early by farmers.
Dr. Mahmoud's model begins by detecting the face of the sheep. Once it's done that, it's able to identify important landmarks in the face, such as the sheep's eyes, the nose, and the ears. These features are then used to classify and predict pain levels in sheep. The boxes around the sheep indicate probabilistic pain levels. Green means healthy sheep, and red means sheep experiencing some levels of pain.
The goal of my research is to be able to do some continuous monitoring of the flock by setting up video cameras to collect lots of footage of the animals without any human intervention. And by analyzing these videos, we can predict early signs of diseases using machine learning models and AI models. I'm also looking into extending my work to be applied on other farm animals as well, such as cows and pigs. For a farmer, losing an animal means losing a livelihood. So such technologies that I'm building will help the farms of the future to basically be equipped with continuous monitoring and screening of the animals in the farm, which will allow for early detection of any signs of pain or disease. Early interventions will be much easier and also reduce the time and effort needed by the farmers to run the farm. As a computer scientist, I didn't know a lot before about animals or sheep. Now I'm learning a lot.
I think another lesson we can draw from this is that the liberal, inventive, fun environment that characterized our lab in Cambridge and many other labs in Cambridge could sometimes lead to innovations that might not otherwise have happened.